I am Dr.D.Arivukarasan, Assistant Professor, Department of Physics, Bishopur College. Today I am going to briefly discuss about semiconducting material. The semiconducting materials are widely used to design various electronic devices such as diode, transistors and integrated circuit. If you want to learn the working of electronic devices, you must understand the basics of semiconducting material. Why these semiconductors are used in electronic industry? To understand this, first of all we need to learn the classification of material according to their conductivity. Based on the conductivity, the materials are classified into three categories. One is conductor, another one is semiconductor, finally we have insulator. The conductivity defined as how easily the materials allow the charges pass through them. The conductivity of the material can be measured by the unit of Siemens per meter. Next, conductor. Conductor is a material, it has very good conductivity. Suppose you can say like this, that those substances allow the charges pass through them, such a materials we called conductor. Example for the conductors are copper, gold and aluminium. If you take copper, the conductivity of the copper is around 10 to the power 7 Siemens per meter. Next, insulator. Insulator has poor conductivity. Those substances cannot allow the charges pass through them. Such a substance we called insulator. The examples for the insulators are wood, glass and Teflon. If you take dry wood, their conductivity is around 10 to the power minus 14 Siemens per meter. On the other hand, we have a semiconductor. Semiconductor is a substance, it have their conductivity in between conductor and insulator. The examples for the semiconductors are silicon, germanium and gallium arsenide. These are some properties of semiconductor. The resistivity of the semiconductor is less than an insulator but more than a conductor. The semiconductor has negative temperature coefficient of resistance. That means when you increase the temperature of the semiconductor, their resistivity decreases. When a suitable metallic impurity is added to a semiconductor, we can change their electrical conductivity appreciably. This is one of the unique property. By using this property, we can make different type of electronic devices. Now we can understand the behavior of semiconductor by using silicon atom as an example. The atomic number of silicon atom is 14. So it has 14 proton and 14 electron. The 14 protons are reside in the nucleus. The 14 electrons are revolve around in the in different orbital. The first orbital have 2 electron, second orbital have 8 electron, third orbital have 4 electron. The outermost orbital generally called valence electron. When the silicon atom combine to form a solid, then they arrange themselves in a periodic manner which is known as crystal. In this silicon crystal, the silicon atom share its valence electron with the neighboring atom. The sharing of valence electron happening in such a way that each single silicon atom has 8 valence electrons in the outermost orbital. By the way of sharing valence electron, this silicon atom make covalent bond. At absolute zero temperature, in the silicon atom, all the electrons are engaged with covalent bond. So there is no free electrons inside the silicon crystal. At this condition, the semiconductor act like an insulator. At above absolute zero temperature, due to the thermal energy, the electrons are come out from the covalent bond due to the breaking of covalent bond. That electron generally we called free electrons. The depart of free electrons in the covalent bond create a vacancy. That vacancy is generally we called holes. Even in normal temperature, we can observe few numbers of free electrons and few holes inside the semiconductor. Types of semiconductor. Semiconductors are classified into two categories. One is intrinsic semiconductor, another one is extrinsic semiconductor. The intrinsic semiconductors are pure form. There is no any another impurity atoms. On the other hand, we have extrinsic semiconductor. To enhance the conductivity of the intrinsic semiconductor, we are adding some impurity to the intrinsic semiconductor. So the adding of impurity is called doping. Depend upon doping, we have another two type of extrinsic semiconductor, such as N-type and P-type semiconductor. Next, N-type semiconductor. When small amount of pentavalent impurity is added to the pure semiconductor, it is known as N-type semiconductor. The examples for pentavalent impurities are arsenic and antimony. If you look pentavalent impurity electronic structure, you can see 5 valence electrons in the outermost orbital. So generally pentavalent impurities are called as donor impurities. When you add dopant pentavalent impurity to the pure semiconductor, the 4 valence electrons are combined to form a covalent bond. 1 electron become free. Suppose if you add 1 arsenic or antimony to the semiconductor, it produces 1 electron. Suppose if you add few milligrams of pentavalent impurity, it make more number of electrons inside the semiconductor. Next, P-type semiconductor. When small amount of trivalent impurity is added to a pure semiconductor, it is known as a P-type semiconductor. The trivalent impurity generally called as acceptor impurity. The examples for trivalent impurities are gallium and indium. If you look the electronic structure of trivalent impurity, the outermost orbital have 3 valence electron. When you substitute this, when you incorporate this trivalent impurity to the semiconductor, 3 of the electrons make covalent bond, 1 place is vacant. That vacant generally we call holes. So 1 trivalent impurity create 1 holes. When we add few milligram of trivalent impurity, it generate numerous number of holes in the semiconductor. Next, majority and minority charge carriers. If you take N-type semiconductor, the majority charge carriers are electron, minority charge carriers are holes. In the P-type semiconductor, the majority charge carriers are holes and minority charge carriers are electron. These semiconductors are that means N-type and P-type semiconductors are extensively used to fabricate various electronic devices like diode, transistors and some integrated circuits. Thank you.